Hello, welcome back to Cracking the Cryptic. And Alf Smith has been at it with his gold cells again, which are a form of friendly cell, but don't just jump in and assume it's the sort of friendly cell we've seen before, because it can be different. I will go through the rules of this puzzle in a moment. We do like Alf's contributions. We will be talking I'll be talking for a minute about what we do apart from our 2 Sudoku videos a day that I hope you enjoy. We also have a Patreon site where you can get even more Sudoku to try. You can get monthly Sudoku hunts there where they come out on the 1st, their competition's till the 20th. At some point after the 20th, if you're on the tier 1.5 or above, you get to see extra solution videos, so more Sudoku solving by Simon and myself. There's also, of course, Patreon and Gridogram and Connections videos on Patreon, and some super hard crosswords, cryptics from the listener, or sometimes from other sources, the Times Monthly Club Special, for instance. So Patreon is a fund of extra puzzles, and so are our apps, which feature Classic Sudoku 2 and the Worms, and they include Worms by Fistamafel and Zetamath and Blobs and Michael Lefkowitz, and these are great things, great fun. So do check those out. We've also got a bit of merch if you wanted a t-shirt or a hoodie with CTC, Cracking the Cryptic, on it. Lots of designs, including Marty Sears Rat Run merch, so have a look at that. But the first link under the video is to Clueless Minimax by Alf Smith. And we're going to go through the rules. Normal Sudoku rules apply, so 1 to 9 will go in every row, every column, and every 3x3 box. The middle cell of the central box is less than its orthogonally adjacent neighbours, so each of these cells is larger than the central cell. For each of the other boxes, the central cell is greater than its orthogonal neighbours, and you can tell that from the directions of the greater than signs sitting in them. A gold cell contains its position within its row, column, or box as its digit. So a position is read from left to right, top to bottom, within a box. This is position 1, 2, 3, 4, 5, 6, 7, 8, 9. So this gold cell, the first one in the puzzle, is in row 1, column 5, position 2. That's a really bad one to try, because that is also box 2, which is what you might have been expecting from a gold cell. Let's do this one instead. Row 1, column 8, box 3. So this digit in this yellow cell will either be 1, 3, or 8. Now, in a similar way, this digit cannot be 1, 7, or 3, because all possible gold cells are given. There's a negative constraint on the gold cells. So that's pretty tricky. Give it a try. You can watch me struggle with it now. I don't know how long it's going to take. You can look at the video length. But I'm going to start now. Let's get cracking. You may think it's a very mechanical way to do it, but I am going to be marking all of the candidates. So these are in row 1. These are in row 2. This one's in row 3. These are in row 4. That's in row 5. These are in row 6. This is row 7, row 8, and row 9. I mean, this might take me a minute to do, but I think it'll be a valuable minute. Those are in column 1, column 2, column 3, column 4, column 5, column 6, column 7, column 8, and column 9. And then as for position within the box, this is number 2. This is position 2, 4, 6. Position 3, no, that's position 6 and position 9. That's position 6 and position 7. This is position 1, 7, 9. 1 and 2. And then if we go down here, that's position 4, 5, 8, 9, position 2 and 9, position 1 and position 3. And these candidates, if I've done that exercise correctly, these candidates are the only possible candidates for these gold cells. So let's home in on this gold cell, which has actually got markings in it. This has to be bigger than the surrounding ones. I'm going to rule out 2 because they can't all be 1. Now, if that was a 5, this would be 2. These would be 1, 4, 3. This would be 9. And these would be 6, 7, 8. I mean, that does... I don't think that can be eliminated, I'm afraid. Okay, this cell has to be bigger than this one, so that can't be 9. For this to be 8, this would have to be 9 now. That hasn't really got me very far. Anything else pointing to a 9? No. This one is less than all of these. That doesn't really help there. Now, is there any chance of me finding doubles or triples? And the answer is probably not. I just don't see... Oh, there's a pair, 6, 9 pair in this column. But how can I use... Well, one of them is 6 and one of them is 9. I don't know, that's tricky to use. Oh, this digit is 5 or 8. This one can't be 8 or 9. It wouldn't allow it to be less. So that is a definite 2. I've got a digit, guys. It's not wildly helpful though, is it? Oh, goodness. How on earth do we compute this puzzle at all? I mean, I've thought of a slightly interesting point. Most of these central digits cannot be 9. They're all in position 5 in their box. Oh, yeah, apart from that, none of them can be 5 because they're not yellow. That's quite interesting. I hadn't thought of that. But anyway, most of them can't be 9. The exception is box 9, where it is box... Oh, no, even that is in row 8, column 8, position 5. So since none of them... Oh, no, I've got the rule the wrong way round. They can all be a 9. Oh, that's no use. Well, maybe that other point that I was thinking about then is good, because in a column, they can't all be 9. It's not that good. No, it is interesting. In this column, where are we going to put 9? We can't put it here or here, or here or here, because, sorry about that, because that would make the central cell of its box a liar, and we can't put it here. So it must be in one of these 2 places. Now, because of this central cell being a minimal cell, that doesn't work so well in column 5, but it does work in this column, where 9 again must be in one of these central cells, otherwise it will be next to 1. The same is true in row 2 and row 8, where we know 9's not there, so it's either here or here. Now, I have marked across boxes for this. What are these positions of 3 different 9s, or can you get away with only 2 being there? You could get away with only 2, because I have not been marking up row 5, column 5 and row 5. So these might be 2 9s. And then, do you know, I do know why that won't work, actually. That's quite interesting. I had not thought of this. Right, the reason these can't be the two 9s and then us not worry about 9s in row 5 and column 5 is because you have to then ask, where would the 9s go in row 5 and column 5? Their current get out clause is that you could avoid putting 9s in like what I'm talking about is, does one of those have to be a 9? And the answer is no in this row, because the 9 might not be in one of these boxes. It might be in this box, in which case it would be there or there. But if you tried to avoid putting a 9 in either of those places, you would have to put a 9 into one of these two. And then where's the 9 in the central column? Well, it's not here or here. It's obviously not in the middle. So it would now have to be in one of the top or bottom boxes. And if you tried to get away with dealing with row 2, row 8, column 2 and column 8 by putting 2 9s there, you would find that you'd effectively need a 9 in row 5 in one of those and a 9 in column 5 in one of those. And that's impossible to sustain together, because that would be 2 9s in the box. So these positions I have just sort of pencil marked must account for 3 different 9s in the puzzle. It just didn't work if we tried to keep it down to 2. The 9 in row 8 and row 2 and column 2 and column 8 must be in these cells, and we can't just do it with 9s there and not worry about row 5 and column 5, because box 5 will break. So what I've now highlighted is, I'm going to use a color because otherwise I'm just getting wildly complicated in my head. 3 of these light blues are definitely 9s. I don't know. I'll be very disappointed if this doesn't help. Maybe it won't. Maybe it doesn't. If that digit was a 9, that would resolve this as 6 and this as 9. If that digit was a 9, this would have to be a 3. Where I was originally starting from when I was looking at these other cells is, and thinking about 9s, was what happens to 8 once you've put 9 in this column, say? It's not so useful, because if you put 9 there, 8 could be riding either side of it. This is not this interesting dynamic really only works. I've got something here. Right, what I have said now is that these light blue cells are going to be populated by 3 9s, 1 each in row 2, 5 and 8, 1 each in columns 2, 5 and 8. And that means that in row 5 and column 5, 9 is in one of those 2 cells, not in these. And in column 5, it's in one of those 2 cells, not in these. So if none of these can contain 9, look at the pencil marking. 9 can't be there. 9 can't be here because of the 6-9 pair. So this is the 9 in box 5. And this digit is a 6. That's quite interesting. If that was a 9, this digit would have to be 9. And that would leave me a blooming X-wing in rows 2 and 8 that's totally unresolved. So that's not very powerful. This central digit is going to be 1, 2, 3 or 4. Because it has to be smaller than each of these. Might have to get myself some water so I can get through this while talking. Sorry. I shall be back with you in a second. Right, let's see if we can solve this before my enormous ice cube is fully melted in my little glass of water. Now, 9 was not going to be in these cells. Well, we know it's there. Sorry, these are all going to be higher than that, which therefore can't be as high as 5, and it couldn't be 5 because it's not gold. Now, what else can we say? I'm very tempted to work on this cell and try and work out why 5 won't work there. If that was 5, these would be 1, 3, 4, and that would be 9. We'd have to put 8, 7, 6 in these cells. I'm very bad at knowing. This was column 6, yeah. I was about to panic and go, why isn't this cell gold? It is gold, Mark. Just look at it. Column 6, that's why that was gold. Now, I'm not getting on cleverly with this. 6 in the central box has to be in one of those cells. The tiniest bit of Sudoku I can do. I suppose 2 in this box, at least we know it can't be here. Actually, 2 and 6 are. No, not 2 and 6, but 2 can't be in these cells by Sudoku. And it can't be here because you can't put 1 in all of these. So 2 is in one of those cells. Now, what about 6? It's quite likely to be in one of those too, but I suppose it could be here. Then this would be the 9 in row 8. I don't know what to do about that at all. Goodness, there doesn't seem to be a lot of help in this puzzle. Is that negative constraint really useful now and I can't work out why? Yeah, I mean, maybe it is. Maybe. Where's the 1 in box 1? I mean, that is very interesting. That's so peculiar. The 1 can't be in row 1 or it would be gold. It can't be in column 1 or it would be gold. And it can't be in this cell. So it's all about the negative constraint. The 1 in box 1 has to be there. This is not going to be an easy cell. I'm going to ask where the 9 is in box 9 next, but actually after I've done those 2 digits in those 2 boxes, I don't think this is all going to be following a, like a trail of dominoes being knocked onto each other. Where's the 9 though in this box? It's not. Oh, it could be here because oh, bother. Oh, I thought this was going to be a big deal straight away, and it's not. 9 could be in this gold cell. Otherwise, it can't be in column 9. It can't be in row 9. In fact, there's the question. Where is 9 in row 9? It has to be in a gold cell. You see, I'm suddenly remembering this from Alf Smith's previous puzzles, which were probably years ago that I've done. And it's taken me ages, but this is the key insight at 1650 on the solve. There is a 9 in this row, and it must be in a gold cell because it would have a gold cell to be in row 9. So it's there. Look at row 5. There is a 5 in this row, and it must be in a gold cell, and there is only one gold cell. So there. Where's the 3 in row 3? The only gold cell. This is how to start the puzzle. Now, We don't know about the 1 in column 1. We found the 2 in column 2 and the 3 in column 3. One of these is definitely a 4 in column 4, so that central cell isn't. One of these two is definitely a 5. We've found the 6. One of these 3 is a 7. One of these two is an 8. Why is this not marked with a 9? Because of its location. In fact, that's a 2-6 pair. But there's only one cell that can now be a 9 in column 9. And now this can't be a 9, and we need 3 9s in the blue. I think the deduction about the blue cells was by far the stronger deduction that I made. Working out how we can find some of the yellow digits was quite minor in retrospect. Anyway, now I can delete 2 from there because of this 2-6 pair. Okay, well that feels like a proper start. I mean, I'm not in any way finished at this point. One of these is a 7, one of these is a 6. There may be some way of deducing something out of that. Obviously one of these is a 2, one of these is a 1. But if this was a 1, this would have to be the 8 in column 8. And this logic doesn't apply to position number, because there doesn't have to be, if there was a disjoint subset rule, great, but there doesn't have to be a 1 in a position 1 in this puzzle or anything like that. So maybe we only get the digits that I've now done from this theory, from this scheme. And I still haven't resolved all the blue 9s. Let's just get rid of the blue from those cells. There's 1 9 in column 8 there somewhere, and 1 9 in column 2 here somewhere. Right, this digit has become 1, 2, or 3. Now that became a 5 in row 5. Is that of any interest? 5 in box. One of these two is a gold 5 in box 5, in column 5. And that means that these can't be a 5, and these can't be a 5. This must be the 5 in box 5. And now one of these 3 is a 5. They're all in row 6, column 7, 8, 9, position 7, 8, 9. Can't use that. But with 9 and 5 there, 8, 7, and 6 can't go here. So at least 2 of them are in these cells. This can't be 3, because 2 would now be in one of those cells, claiming to be bigger. This is 1 or 2 in the center. What about this? What about 8 in row 8? It's in one of these 2 cells. Well, the max cell tells us which one. It's there. So obvious. What about 8 in column 8? That's very interesting. Whichever cell it's in, it's right next to a 9 in the max cell. But that doesn't let me resolve it. No, sir. Some of this is, but one of those is an 8. So these can't be 8s, and these can't be 8s. So the 8 in box 9 is now in one of those 2 cells. And that means there's an 8 in one of these 2. Eight, 2, 9, 5, 3. These digits are from 1, 4, 6, 7. Yeah, you see, this is how to do it, maybe. This digit can't be a 7 because it's in row 7 and it's not gold. This is in position 6 and it's not gold. That's a very difficult way, though, of doing the puzzle. It's exactly the sort of thing I expected to find when I predicted I'd struggle at the beginning, and my goodness, here we are. if this wasn't a 9, this couldn't be, sorry, if this was a 9, this couldn't be 8 because it's in column 8 and it's not gold. So it would have to be something smaller than that, and this would be therefore 4, and this would be 1 or 2. And this would become 8. That's quite interesting, but it's not everything, is it? 2, 8, 1. Where's 7 in this column? 7 in this column is not here, because that's in row 7. So 7 is either here with 9 in its adjoining max square, or 7 is here with 9 there. It's quite interesting. But maybe it doesn't butter any parsnips. Right. This row, we've had 2 and 6. We've still got 1 and 3 to place in this row. I don't think they can go in max cells with 4 adjoiners. So 1 and 3 have to be in these cells. That's quite definite. So now we've had 1, 2, 3, and 6 as 2 pairs. Everything else is 4, 5, 7, 8, or 9. None of the maxes can be 4. So 4 is either sitting here, but that's position 4 and it would be gold. If it's not there, it's got to be here. So that's a 4. And this isn't by Sudoku. One of these is the 7 in column 7. The other one is a 1. That's a 4, so this is bigger. That's obvious because it's... Right, how are we going to get 5 anywhere but here? We're not going to put 5 into any of these because they would be in position 5 and be gold. So we're putting 5 here. And by Sudoku, that gives me a 5 here. And that is not a 5 now. And these max cells in this row happen to be 7, 8, and 9. And we've worked out this central one is not 9. This digit can't be 8. It's 7 or 9. This one I don't know about. Right, well that's good. Let's think about 3 in this column. We can't put it here, so we're going to put it in one of these cells. This is row 5, column 2, position 5. It can't be 4 because of that. So the 4 in the column is either here, here, or here. I don't know. That 1-3 pair that we discovered stops this being a 1. This could only be an 8 if that's a 9. Then this will be 7. Then 8 in this box would have to be here. I don't know what that means. I mean, some of the deductions may be very obvious to you. I know that that's the case. All I can do is do what I'm doing. Right. Okay, here's one. 9 can't be there or there by Sudoku. 9 is in one of these 2 cells, but we happen to know it's not here because the 9 in the row has to be in one of these 2 because of our X-wing remaining on light blues. So this digit must be the 9 in box 6. That's the 9 in box 1. This one is not a 9, and nor is this, and these 2 aren't even blue. Right, this can't be an 8. In fact, we worked out that the 8 in this column was in gold next to a 9, so it's there. This is not an 8, this is 1 or 2. Now we do need a 1 in gold in row 1 there. We need a 4 in gold in row 4. This was worth checking again. 6 in row 6, 7 in row 7. We've had the 8, we've had the 9. We need a 1 in column 1, 2, 3, 4. We need a 5 in gold in column 5. That's here now. 6, 7 in one of those, 8, 9. Okay, well that was worth checking. Now 5 there, 5 there. There's a 5 in one of these cells. 5, 8, 2, 9. There's a 3 in one of these two, which need to think about these. They're not in position 3, so don't worry. Gosh, this is such a strange puzzle, and I probably keep forgetting the rules. That might be quite a handicap. Right, the digits to put in this column are 3, 4, 6, and 7. This has to be bigger than 2 of those. So this is 6 or 7. It's position 5 in row 5 in column 2. There's no problem with that. It's 6 or 7 though. So where do 8 and 9 go in this box? 8 can't go in those positions, and by Sudoku it can't go there. So 8 is found. Then 8 is going to be in one of these two in box 5. 9 has to be in one of, well, it has to be here by Sudoku. Is that the last 9? No, there's still 2 to go. That's quite surprising. I'm going to pencil mark the other 2. I did see something a moment ago and I haven't used it yet. It's about 8. It was here, was it? Oh, that digit is 7. This wasn't what I saw a moment ago. Oh, it was an X-wing on 8s that was going to ask me where do I put 8 in column 5. It was going to be in one of these two cells and it was going to have to be in the bigger one, but I just found that by just doing ordinary Sudoku. Okay, that's good. Now, this can't be a 4 by Sudoku anymore. Okay. It's a clever puzzle. You've got to admit it. It really is pretty clever. 9, 4, 5, 8, 1, 2. This is 3, 6, or 7 by Sudoku, but it has to be less than the middle. So that's 3 or 6. It's in position 2 in row 4, column 2. No negative constraint applies to it. Now, this is a 7, so it's legitimate to ask where 9 and 8 go in this box, because they don't go here. No, it doesn't really do anything. This digit is very interesting, because it can't be 9, 8, or 7, but it's in a central cell, where it's got to be bigger than 4 others in the box. So this is 6 or 5, and these are from below 6 or 5. Could this be 5 with 1, 2, 3, 4 around and 7 there? No, because these would be 6, 8, and that would clash with this 6. So this has to be 6. It is basically the only place in this box where 6 can go. These can't be 1s. I don't know why I so enthusiastically pencil mark the whole blooming box. 7 in the row can't be in this box. It's in one of those two cells. Oh no, it could be there. I hadn't even noticed that. Bother. Oh, that was going to be very powerful if I could have said 7 was definitely in one of these. 3, 5, 8, 9 in this column. That can't be 4. This can't be 1. No. No, not any use. This digit is not allowed to be 6 in this row because it's not gold. So it's 3 or 4. It can't be 7 because of this cell. Now that's not allowed to be 3. This digit sees 1, 7, 8, 9, 6, 4, and 3. That is 2 or 5. It's in row 3, column 8, position 8. That doesn't rule any of them out. 985. This, right, where's, if that was 2, where would 1 be in the box? Impossible. So that's a 1 in the center. And after doing that, it's clearly not going to tell me anything else. Or, well, I mean, almost. It says that 1 is in one of those 2 positions in box 4. Yeah, well, I mean, it's not rubbish. There's a 3 in box 1 in one of these 2. Oh, but that's position 3 in the box, so 3 can't be there. So 3 must be here. 3 can't be there because it's not gold. So 3 must be here, and that makes this 9 and this the last 9. And 8 is in one of these 2 cells now, and that positions it in the bottom box, in box 9, as there. That's good. I'm not going to sniff at that. These include 2 and 6 in this box, so this digit is not 2. And indeed 2 in box 6 has to be in one of these 3 cells. Just rechecking that each row has its row number in gold and each column its column number in gold. Unfortunately, that is all taken care of now. I mean, I wasn't good at spotting its usefulness, but now I've done it, I'd like it to contribute more, and it won't. That can't be 2 either. 2 is now in one of these 2 cells. It can't be here. This is position 2 in the box. Ah, goodness. So 2 must be here by elimination. And now we know there's a... No. I claimed that these cells had 2 and 6 in. I chose the wrong digits, 6 and 8. I cannot say 2 was not here. Sorry. 2 is in one of those 2 cells. It can't be here because of position 2. It can't be here because of that. But this was not ruled out. That was me making a mistake. So, okay, this does still give me something. It means that 2 in this box is in one of these 3 cells. I was going to say one of those 2 along with 8. But it's in one of those 3 because it could be in the gold cell there. Okay, well, that gave me nothing worth having. Bother. What I really need to do is check for the pencil marks I've put in white cells and see if any of them are impossible. Like this one is in position 4. That's not possible. Actually, it sees a 4 and a 3 in the column. It also sees a 1-7 pair. That's quite interesting. So it is 2 or 5. I mean, it might well be a 2. This is 2 or 6. It sees this 1-7 pair in its column. And this is 2, 5 or 6. But I can rule out 6 because it would be gold in row 6. So that's now a 2-5 pair, and this digit is 6. And that means this central digit is 7, and this one isn't. That's not going to do much else in that position, but we need a 4 either there or there, but this is position 4 in its box. So that must be the 4 in the row. Now 4 is definitely in one of these cells, being inferior to 6. Wow, I wish I could do some Sudoku here, but really that's beyond me. This, I can do this digit. 751694 in the row, 8 in the box, and also 3 in the box, which has to be in one of those cells. So this is 2. And this is now a 3-8 pair. And that's a 3 X-wing. And the 3 in the central column has to be here at the bottom. And that's not a 3 now. Wow, where is 3 in this box? It's in one of those 2 cells. And that 3-8 pair means these digits are from 2, 6, 7. That's a triple in this column, and that digit is a 4. And that's going to mean 4 is in one of these 3 cells up here. Which is, one of these 2 is the 6 in this 2, 6, 7 triple. Isn't that right? Yes, it is right. So this digit can't be 6. That has to be 7. Now row 6 needs a 6 in gold, and that's there. Now column 1 needs a 1 in gold. This is good. Okay, well, that's about it for that. Goodness me, but we are getting somewhere now. That has to be a 3 because we placed 6 in the box. That has to be a 4. We can complete the column with a 6. Then we can do the 2, 6 pair in yellow in row 2. This is a 1 to complete the box. That makes this a 7, which makes this a 1. We need a 7 in gold in row 7, and all the gold cells are complete. Now, we may still have to use the negative constraint a bit. This has become a 2-8 pair. 2, 8, 7, 1, 9, 5. This can't be 5. This is 3 or 4, and there's only one place for 6 in the row, and that's here. In this column, we need 4 and 7. 1, 8, 3, 9, 5, 4. We need to place 6. And then we've got a 2, 7 pair. Neither is in position 2 or 7, but they see this cell, and that's going to sort out the 8 X-wing, and that 3 sorts out 1 and 3 as well, and this digit is a 4 to complete the column. These are a 5, 1 pair. They're done. That's a 7. This is 4 in the corner. That's 3. This is 4, 5, and a 7 in the corner. That's now 2, and this is whatever's left, which is 3. This has become 2. We've got 5 and 8 to put in box 3. I'm going to get rid of my light blue colouring because we are approaching a finish now. This is 1 and 2 here. And that can't be 2, so that's 5, that's 3. This is 2 and 6, 7 and 2, just box 1 to do. That's a 4, that's a 7, and 8 to finish. And there is the solution to Clueless Minimax. What a clever puzzle. How difficult that is to me. It's so annoying that I think years ago I discovered that with this rule set, you have to have a gold 3 in row 3, and therefore with only one cell there you can write it in. And that had totally escaped my memory. But there we go, we had to work it out again, and there's got to be value in that. Thank you for watching. Such a pleasure to bring you these puzzles, and I'd love to see you again tomorrow. Bye for now.